Okay, last problem. Here comes the proof. Remember, with every mathematical induction proof, you have to show all 3 steps. Step number 1, when n equals 1. Yes, you have to write it out. Take the first term from your list. If this is 5, write 5. If it's 28, write 28. In our case, it's 1. And yet, we're saying, hey, n equals 1. So does 1 equal 1 4 times 1 plus 3? Is that true? I don't know. Well, I got 1 equal 1 4 times 4. And heck yeah, that equals 1. So check. N equals 1 works in the equation. Second step, we're going to make an assumption. We're going to assume that this series is true. Recopy it. Don't be lazy and not write it down. We're going to assume this is true for some value of k. So all of the n's will be replaced by k's so that you know in the next step, if that's true, I can use it, right? Check. Last step, here's the algebra. What are we doing? We're trying to show that this is true. And again, recopy it. Don't cheat it. It gets its place in the sun too. Recopy it. But I'm not just going to keep the same thing. I'm going to add on an extra term. We can do this a couple ways. We can recognize the pattern, which is increasing by half. Honestly, though, this one's a little tricky. If I just put k plus a half, it's not right. So your second option is replacing all of the k's with k plus 1s, and that's what I'm going to do. So k plus 1 makes a k plus 2 in there. I'll do the other side of the equation. All the k's become k plus 1s. So k plus 1 over 4, and k plus 1 plus 3 turns into k plus 4. That's what we're trying to show. Remember, the important step now in showing this is the substitution. We said in the step before that from 1 to 1/2 k plus 1 was that expression right there. So now I'm going to use it. I have from 1 to 1/2 k plus 1. I'm going to put in its place k over 4 times k plus 3. But I need to add on the extra term of 1/2 k plus 2. Does that equal k plus 1 over 4 times k plus 4? If it does, we're in good shape. If it doesn't, then we did something wrong. Okay, so now simplifying. These both have fractions already. If one has a fraction and one doesn't, you better be thinking common denominators. I still need common denominators. So I'm going to change this 2 into a 4. Top's going to become a 2. So what we have is k times k plus 3 plus 2 times k plus 2 all over 4. And that's good. That's over 4, just like the answer needs to be over 4. Do some distributing. So k squared plus 3k, but then I'm going to have a 2k, so I'm going to go to 5k plus 6 over 4. What's the problem? Okay, just figured out my dumb mistake. Took me a second. 2 times 2 is not 6, it's 4. There we go. Okay. All right, so remember our goal is to get this to be k plus 1 over 4 times k plus 4. Hopefully this will factor into k plus 1, k plus 4. So what multiplies to be 4 and adds 3, 5? Hey, imagine that. It's k plus 1 times k plus 4 all over 4. Once we have the match, we're done, and cutie.